For decades, people have been told one simple answer for why the woolly mammoth went extinct. Either the climate killed them, or humans hunted them to death. But here's the thing almost nobody talks about. The real answer is stranger, slower, and honestly a lot more interesting than either of those. Woolly mammoths weren't some short-lived species either. They walked the Earth for roughly 700,000 years, surviving multiple ice ages, multiple warm periods, and massive shifts in climate, long before humans ever showed up in most of their range. So the real question isn't just what killed them. It's why this particular ending was different from every other hard winter and warm spell they had already survived before. Let's start with the climate theory because it's the one most textbooks lean on. Around 15,000 years ago, the Ice Age started ending, and the planet warmed up fast, at least in geological terms. The dry grassland that mammoths depended on, called the Mammoth Steppe, started disappearing. It got replaced by wetter forests and boggy tundra, which sounds like a small change. But it wasn't. Mammoths needed huge amounts of tough, dry grass every single day just to survive. A single adult could eat well over 100 kilograms of vegetation daily. And that only works if the landscape can actually produce that much food. Forests and soggy wetlands simply couldn't feed a herd that size. Trees also break up the open sightlines mammoths and other steppe animals relied on, and wet, boggy ground is far more dangerous for an animal that heavy to move across. So on paper, climate change alone looks like more than enough to wipe them out. And for a long time, that was basically the whole story scientists told. But then people started asking an uncomfortable question. If climate change did this alone, why did mammoths survive multiple earlier warm periods without going extinct? The Earth had warmed up before, more than once, during the Ice Age, and mammoths made it through every single time. So something about this particular warming event was different. And that's where the second theory comes in, the one people call overkill. This is the idea that humans, spreading across the world with better weapons and better coordination, hunted large, slow breeding animals like mammoths faster than they could reproduce. Mammoths had long pregnancies similar to modern elephants and only had a handful of calves across an entire lifetime. That means even moderate, steady hunting pressure could slowly grind a population down over centuries without needing constant mass kills. There is real evidence for this too. Archaeological sites show mammoth bones with cut marks and embedded spear points, proving humans absolutely were hunting them in some regions. Sites in Siberia and parts of North America have produced spear points still lodged in mammoth remains, along with butchery marks that clearly show deliberate, skilled processing, not accidental scavenging. Some researchers have also pointed to how quickly certain mammoth populations vanished after humans arrived in previously unpopulated regions, which is exactly the pattern you'd expect if hunting pressure was a major driver. And the timing lines up in an uncomfortable way. In many parts of the world, human populations expanded into new territory. Right around the same time, mammoth populations started crashing. So now we have two theories that both have real evidence behind them: climate change and human hunting. And for years, scientists genuinely argued about which one mattered more. Here's a theory that gets way less attention, but it's not fake. It's part of a real ongoing scientific debate. Some researchers have proposed that disease, or what's sometimes called hyperdisease, could have played a role too. The idea is that as humans and their animals moved into new regions, they may have introduced new pathogens that mammoth populations had never been exposed to before. To be clear, this idea has much weaker direct evidence behind it compared to climate and hunting. There's no confirmed ancient mammoth plague that scientists have found preserved in the ice, but it's still discussed as a possible extra factor, especially for explaining why some populations crashed unusually fast. So which one actually did it? Climate, humans, or disease? Here's where the real answer gets more interesting than any single explanation. Most researchers today think it wasn't one clean cause at all. It was multiple pressures hitting mammoths at the same time, each one weakening them further. Climate change shrank their habitat and food supply first. That alone would have already been stressing populations and shrinking their numbers. Then human hunting pressure added on top of an already struggling population. Instead of a healthy, thriving one, a species already stressed by habitat loss has almost no room left to absorb extra pressure from hunting. Think of it less like a single knockout blow, and more like a population getting squeezed from two directions at once, with less food, smaller ranges, and fewer safe places to raise calves, all while facing a new predator that hadn't existed in their world before at this scale. And that combination is a much better match for what the fossil record actually shows, since different regions saw mammoths disappear at slightly different times depending on exactly how hard climate change and human pressure hit each specific area. Some pockets held on far longer than others simply because the local habitat held together a bit better, or because humans arrived there later. But there's one more piece to this story that most people have never heard, and it might be the most fascinating part. The very last mammoths on Earth didn't disappear on the mainland at all. A small, isolated population survived on Wrangel Island in the Arctic Ocean, long after mainland mammoths were already gone. Rising sea levels cut this island off from the Siberian mainland around 10,000 years ago, trapping a handful of mammoths there, with no way to leave and no new mammoths able to arrive. They lived there until roughly 4,000 years ago, which means these mammoths were alive after the pyramids of Egypt had already been built. Picture that for a second. While early Egyptian dynasties were carving hieroglyphs and building monuments, a small herd of woolly mammoths was still quietly grazing on a frozen island in the Arctic, completely unaware that they were the very last of their kind on the entire planet. For a long time, scientists assumed this last population simply died out from the same climate and human pressures as everyone else. But then, a genetic study changed the picture completely. Researchers managed to sequence the genome of one of these very last Wrangel Island mammoths. And what they found was almost tragic. The population had become so small and so isolated that they were inbreeding heavily for generations. Their DNA showed a pileup of harmful genetic mutations, affecting things like their sense of smell, their fertility, and even the texture of their fur. Some of these mammoths likely had unusually shiny, translucent coats instead of a proper thick winter coat, simply because the genes controlling fur texture had started breaking down from generations of inbreeding. Their sense of smell, which mammoths would have relied on heavily to find food and detect predators, also showed signs of genetic decay. In other words, this final population wasn't just shrinking in numbers. It was slowly falling apart genetically from the inside, generation after generation. Scientists call this genomic meltdown, and it's an incredibly rare thing to actually catch happening in ancient DNA. So the very last mammoths on the planet may have been undone by their own broken genetics, isolated on a remote island with nowhere left to go. That's the part almost nobody puts in the textbook version of this story. It wasn't a single villain. It wasn't just spears, and it wasn't just melting ice. It was climate change, shrinking their world. Human hunting adding pressure at the worst possible time. And finally, a small, isolated population slowly breaking down at the genetic level until there was simply nothing left to keep going. What makes this story hit differently once you know all three pieces is that none of them alone would have necessarily ended the species. Mammoths had survived warming before. They had survived predators before, including humans in some regions for thousands of years without going extinct. It was the specific, unlucky combination and then the slow genetic unraveling of the very last isolated group that finally closed the door for good. And in a strange way, that makes the woolly mammoth's extinction feel less like some ancient, inevitable disaster, and a lot more like a cautionary tale about what happens to any small, isolated population when it runs out of room to adapt. If you want to see what those final years might have actually looked like for the last mammoths on Wrangel Island, let me know, because that story alone deserves its own video.